Alright, next what I'm going to show you is how do we find the zeros of a function. Similar to what we did in the last section. Actually, it's very similar, except now we have the possibility of complex zeros showing up as answers. And essentially it's backwards what we just did. Instead of giving you zeros, find the function, here's the function, find the zeros. So basically undoing what we just have done. Now if you recall from the last section, the first thing we do is we list out all the possible, and these aren't possible zeros, they're possible rational zeros. So the factors of 24, which are 1, 2, 3, 4, 4 pairs with 6, 3 pairs with 8, 2 pairs with 12, 1 pairs with 24. Yikes, there they are. All the possible factors of this number divided by all the factors of 1. Well, all the factors of 1 are just 1, so all these numbers here divided by 1 are just these numbers. Okay, but we see there are 16 possible zeros. Possible rational zeros. There's only 5 total. And some of those 5 might be imaginary, might be complex, might be irrational. So there's no guarantee that the 5 that we're looking for come from this list of 16. Therefore, I don't want to just blindly start doing that, dividing. So we are definitely going to graph this to try and narrow down our search. So let's see, I'm going to put it down here and just type them in. I'm assuming you're doing the same. Alright, this looks like, from my graph screen, and hopefully yours shows the same, that it crosses at -3, +1, and +2. So I'm going to look at those 3. That might cross at some others because I've got 12 and 24 on the list, and those are outside the visual screen of my graph right now. But let's just begin with those 3 and see if we can confirm that they are actually zeros of this function. So we've got 1x to the 5th. We have 0, careful there, we have 0x to the 4th, -3x to the 3rd, 6x squared, -28x, and 24. We are looking for 0. And I'm just going to try +1. So we bring down and we multiply. Add and we multiply. Add and we multiply. Add and we multiply. Add these together and we multiply. And sure enough, it is. Okay, now let's continue this. Again, I'm looking for a remainder of 0. This time I'm going to try the +2 that the graph showed. So we bring down the 1 and we multiply. We add and we multiply. We add and we multiply. We add and we multiply. And that works. And I'm going to do one more, because the graph also showed -3. Bring down the 1. Multiply together, we add. We multiply together, we add. We multiply together, and that works too. Okay. Now, what's left over? Let's see, I'll write them in here. I started x to the 5th. Divided out, this was x to the 4th. Divided out, this was x to the 3rd. Divided out, this is now x squared. So what I have left over down here at the very bottom is x squared plus 4 set it equal to 0, and we'll finish solving it just kind of the old-fashioned way. I'm going to minus 4, so x squared equals negative 4. If I take the square root, get x equals plus or minus the square root of negative 4 is 2i. They are imaginary. That's why I didn't see them on my graph. Notice there are 2 of them. They're always plus minus paired. Always. So I couldn't get positive 2i without the negative 2i. Okay, so my zeros then are 1, 2, negative 3, plus minus 2i. The end of this says to write as a product of linear factors. Okay, so what is that? How does that look? The product of linear factors is this. It's just really how we started the last problem, is putting it in a factored form. Positive 1 means that x minus 1 was the factor. Positive 2 means x minus 2. Negative 3 means x plus 3. Positive 2i means x minus 2i. And negative 2i means x plus 2i. Okay, so there's our function written as a product of linear factors. This next example asks us to find all zeros of the function, again, write as a product of linear factors. I put this one on the notes because I want you to always remember that what I did on the last problem, I only do if I can't factor the function. Okay, so on this one here, I recognize this is a difference of squares. This is x squared plus 4 and x squared minus 4. Okay, so that is x squared plus 4, x squared minus 4 factors x plus 2, x minus 2. Okay, so my zeros plus or minus 2i, negative 2, and 2. Okay, there was no need to or no business to do all the synthetic division, the graphing, if I could just factor it. It's by far the easiest way to go. Now write it as a product of linear factors. Well, let's see, I've got the x plus 2, I've got the x minus 2, I've got the x plus 2i, I've got the x minus 2i. And of course I could have written those in any order. That was totally irrelevant. I just was randomly grabbing them and throwing them in there. And that's it. So again, always remember, check to factor. If it doesn't factor, then do what the last example showed. Alright, this last example is a little bit different. It says to use the given zero, find all zeros and write a linear factorization. Alright, now the given zero just happens to be complex, but that's not going to stop us. If this is a zero, then that means when we divide it into this polynomial, we will get a remainder of 0. So let's do that. I've got 1 plus 3i. We're going to divide it into this. 1, negative 2, 5, 10, negative 50. It should be a remainder of 0. I know it's a remainder of 0 because it tells me this is a 0. So I bring down the 1 and I multiply. I add these together. I can only add the like term parts. That's negative 1 plus 3i. And now I need to multiply 1 plus 3i and negative 1 plus 3i. And I'm going to not necessarily cheat, but I'm going to use the calculator to do that because it'll multiply complex numbers. I'm going to take 1 plus 3i times negative 1 plus 3i. And it tells me that answer is negative 10. Which adds to negative 5. If I multiply these together, it would be negative 5 minus 15i adds to give 5 minus 15i, and I'm going to multiply again together. 1 plus 3i times 5 minus 15i, and that gives me 50, which is the remainder of 0. Alright, so that is a 0. I've confirmed it. Well, if that's a 0, it means also 1 minus 3i is a 0. So let's try with 1 minus 3i. Bring down the 1 and I multiply. Add together and that's 0. I multiply, that's 0. I add, that's negative 5. I multiply, that gives negative 5 plus 15i, and that's 0. Alright, what's left over is represented by x squared minus 5. If I set that equal to 0, I can find the other zeros, plus or minus square root of 5. Okay, so we've got our 4 zeros. We've got 1 plus 3i, 1 minus 3i, plus and minus square root of 5. We're now asked to write this as a linear factorization, so let's just squeeze that in here. Linear means x to the first, so I would have x plus square root of 5 and x minus square root of 5. To get these, I could have x minus 1 minus 3i and x minus 1 plus 3i. There's my linear factorization.